Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to another GameMaker tutorial. Now, this tutorial is part 2 to my random level generation series, and there's going to be a third part after this one. If you need to see part 1, I'm going to put a link in the video right here that you can check out and go watch part 1. This tutorial is for more advanced students, so if you're a beginner, this might not be the tutorial for you. I have in the first video, there's some prerequisites for it that you can go check out as well. One more quick thing, I just wanted to mention that my Udemy course on GameMaker Studio is on sale for 50% off right now. I just barely put that up, and so you can go check it out. There's a link in the description to my website. So in the course, you build an entire game from start to finish. So if that's something you want to do, you're interested in, go check out the link on my website. Now let's get started. First thing I'm going to do is just run what we did the other day and show you guys. We set up a DS grid and we created a random level using that DS grid, and then we drew that level in our room using some tiles, and we added a space key to where we can cycle through these. So what we're going to do today is we're going to add in collisions, and it's possible to set up a collision system that uses the grid so that we don't have to create multiple objects and have 100, 200 instances in the room. That would cause our game to slow down. It just wouldn't be quite as efficient. So using this method, the first thing we're going to do is create a new script, and this is just going to be a basic move script. Let's see how I named these other things. Level, yeah, we'll just call it move, H speed, V speed. It's going to take a horizontal speed and a vertical speed, and it's just going to attempt to move our character. So var H speed equals argument 0. Var V speed equals argument 1. There we go. Now what it's going to do is we need to check for both horizontal and vertical collisions before we actually move. So horizontal collisions, vertical collisions. Now, if you've watched any of my other videos, this is going to look very familiar to you. If place meeting X, Y, object. Well, we can't really do that for now. We're just gonna do, in fact, we can't check for collisions yet at all. So we're just gonna do X plus equals H speed, and then down here, so move horizontally. And down here, move vertically. Y plus equals V speed. There we go. We're just adding our horizontal speed to the X coordinate, our vertical speed to the Y coordinate. This is going to move our character in the room. Let's actually create a character object. I'm going to create a new sprite. We'll call this sprite player. And I'm going to create a sprite of 16 by 16. I'm just going to make him kind of a blue color. That's fine. And I'm going to center the origin of the sprite. We'll create our player object. Call it player. Give him a sprite. We're going to add a step event to our player, which is going to just get input and move. So var H speed equals keyboard check VK right minus keyboard check. I'm just doing, this is a really simple way to throw out a prototype var vspeed equals keyboard check vk down minus keyboard check vk up. Simple math. Now, I'm just going to move h speed, v speed. We'll pass those in. And you can actually do multiply them by a speed. I'm just going to do a speed of 2 for now. Well, let's do 3. Speed of 3. Times speed. I'm putting parentheses around these calls, or around this, because we don't want it to multiply until after it adds. Well, it's going to subtract first and then multiply that. So I've got the parentheses around those. Okay, our player exists. Let's create it in the room. I'm just going to create it before. So right here, we're going to create our player. Right after we create the controller, create the player. And we're going to do instance create cx times cell width cy times cell height, and then player. There we go. We'll create the player object. It just creates at the very start of the level. Now we're going to set up a view, and views, let me look. We're gonna do a pretty small view. So go into your room. I'm actually gonna rename it room 1, and then go to views, enable the use of views, visible when room starts. Now, I'm not really showing you guys the effect in this one, I guess at the start of the video, because I showed it to you at the start of the previous video, so hopefully you're watching them in sequence. You already know what this is going to do. So the width of our view is going to be 320. The height of our view is 180. It's a tiny little view. The port on the screen, I'm going to set mine to 960 by 540. But you could also do just double these numbers, which is 640 by 360. We're going to make it follow the player. Now let's run the game, and you're going to see that this is going to y plus equals v speed. Oh, typo. I always get a typo on v speed every time. Okay, here we go. Okay, our player is, okay, we need to subtract from the player's depth so that we can actually see it. I'm going to give the player a depth of -10, and we can run the game again. Now you can see our player can move around in the room, but he can go through walls. It's because they're not actually objects there. And also our view doesn't follow the player very nicely. Let's go back into the view and change the horizontal border to 160 and the vertical border to 90. That's half of our view width and view height. Now it should at least follow the player better, even though we still can't collide with walls. You can see we can still just go through walls. That doesn't make sense. Shouldn't be able to move around in our room. Still randomly generate the room. Also, we should probably add, you can see sometimes we actually get created inside of a wall. So what we need to do is go into where we're creating the player, and I think when we create the player right here, we need to add 16, which technically is cell width divided by 2 plus cell height divided by 2. Let's make sure we can't get created inside of the walls now. So I'm just going to hit space a few times. Yeah, that's looking good. You can see we get created right in the middle of that in that wall. Looks really good. Sweet. That's looking good. Now what we're going to do is we're going to do the magic part. I've written a function or a script, and I'm going to show you guys the script that works similar to the place meeting script. So you guys all know how place meeting works. You do if place meeting, and then you pass in an x and a y. So x plus h speed y, and then you do, you know, object solid or whatever to try and check to see if there's a collision at that place. Well, we're going to write a script that works just like that, only instead of checking for a solid object, it checks on our grid. So create a new script, and we're going to call this grid place meeting. Grid place meeting. And we're going to pass in an x and a y. Now let's grab those. Var xx equals argument 0. Var yy equals argument 1. There we go. Now we need to check on our grid, and this gets a little bit tricky. Some of this math does. So I'll do my best to step you through it. This is the hardest part. We need to remember our current position, because what the place meeting does is it actually moves the object to that place, checks to see if there's a collision, and then moves back. So we're going to kind of do that same thing. So var remember our position. Var xp equals x. Var yp equals y. And the reason we actually need to move our object is because when we move it, it's going to update the bounding boxes of our object, or the collision boxes of our object. Because every single sprite has bounding boxes if you look at the mask. And that's the right edge, the left edge, the top edge, and the bottom edge. And those are actual variables inside of GameMaker that you can access. B box, bottom, left, right, and top. But we need to actually move it. So update the position for the B box calculations, because we're going to use those to calculate whether or not we can move onto a place. So x equals xx, right, which is our new position right here. And y equals yy. Now we need to check for an x meeting. So we're going to check only the horizontal position to see if we're meeting there. So var x meeting equals, now this is a big huge chunk of code, because there's we need to check both the left edge and the right edge. So we're going to do a two parentheses, a double or an or. You could type or as well, but I'm just going to do this, and then two parentheses again, and then a semicolon. And then to make things easier to read, I'm going to hit enter on the second one and tab down and leave it right there. So you can see I've got this format here where I've got the double parentheses, the or, and then this. And this is just for readability. You don't actually have to do that. So now I'm going to do, we have our level object, and it has a grid, I think. Yeah, we created a grid. So we need to access that. We're going to do level dot grid. We're going to use our accessors. Accessor, b box right, div, cell width, comma, b box top, div, cell height, and then the bracket, and then does not equal a floor. Okay, so what are we doing in this? Let's take a look. We're getting access to our grid. We're checking our player or the current object's right bounding box divided by the cell width, but only returning whole numbers. So this is going to check that the cell inside of our grid. So this right here converts the player's B box position, B box right, into a cell position in the grid. That's what we're doing. So we're checking this is the X coordinate and this is the Y coordinate inside of our grid, the Y cell and the X cell. Now we're checking the right top corner, you can see B box top and B box right. So that's the right top corner to see if there's a floor there, to see if there's, whether or not there's a floor there. Now we're going to do our next check, which is level dot grid B box left, you guessed it, div cell height. You know what? There's a better way to show you guys this. Well, that's okay. Just remember that this div cell width and div cell height, and this one should be cell width actually, is converting our X coordinate into the room into a cell coordinate in our grid. Because the cells are 0, 1, 2, 3, 4, but the X coordinate in the room is going to be 0, 16, 30, 0, 32, 64, and so on. So there we've got the left B box top. Did I do top? Yep. Div cell height. And our bracket does not equal floor. So let's look at this one more time. I'm going to make sure you guys can see it because I'm worried that my face is covering it up. Our X meeting will only be true if this position in our grid is not a floor, or this position in our grid is not a floor. This is the top right, this is the top left. So if there's not a floor at our top right and not a floor at our top left, or not a floor at our top left, that means there is a horizontal meeting. Now this method isn't foolproof because technically you could happen to move completely on top of the box or the cell and overlap it, but that's not really possible in this case. So, and very unlikely. So now we need to do our Y meeting. Check for Y meeting. I'm going to do the same thing, parentheses or parentheses, semicolon, and then I'm going to do enter and tab over so I can get the same, easier to read. So we're going to do our bottom right now. We could actually copy that, but let's not do it. I'm trying not to copy and paste stuff because I get students who have error messages. So we're going to do our right div cell width, comma, B box bottom now, div cell height. So we're doing our bottom right, not equal to floor. Good. Level dot grid B box left div cell width, comma, B box bottom div cell height, and our bracket not equal to floor. Okay, shouldn't have any red over here. Should be good. Now this is how we're checking for the X and the Y meeting. Once we've done our check, we need to move our player object back. move back. We remembered our position right here with XP and YP. So now we're going to move back. X equals XP, Y equals YP. And there you go. We've written a grid place meeting. And this should be able to use our grid. Now, if you want to get really fancy, you could modify this to where it took in what you're looking for, like whether you're looking for a solid, or I guess you'd call it maybe cell type. So you could check for specific cell types, and that would be useful as well. But I'm trying to keep this simple, so we're just going to check to see if it's not a floor. Basically, it will be either a void or a wall. If it's a void or a wall, we can't move there. Okay, so we've written the grid place meeting. I'm pull it up one more time. If you guys need to pause the video and look at it right here. Hopefully you can see all of it. Grew. I'm trying to make it so you can see all of it. Hopefully you can see all of it. I'm going to check real quick to make sure you can. Okay, you can. Yeah, it just, my face isn't in the way, so that's good. You can see all of it. Now we're going to do our move, and this is going to be really familiar to you guys. It's just going to be the same move that I do normally, only instead of using place meeting, we're using grid place meeting. So we're going to do if grid place meeting x plus h speed y while not grid place meeting x plus sine h speed y x plus equals sine h speed equals 0. Now we need to do the same thing for our vertical collisions. If grid place meeting x, y plus v speed while not grid place meeting x, y plus sine v speed y plus equals sine v speed y, or v speed equals 0. What am I missing? I'm missing a parentheses. Why am I not missing a parentheses up here? Oh, yeah, that's right. Okay. Now let's attempt to move our character in the room and hope that our grid place meeting function works, and it doesn't work. So let's check and see why. It's not equal floor. Cell. Grid place meeting. Just double checking this real quick. Make sure I didn't miss anything with it. Oh, we forgot our return value. Oh my gosh. Okay. That was silly. We have to return either true or false based on whether or not there is a place meeting there. So return either true or false. Return X meeting or Y meeting. So if either X meeting or Y meeting are true, we're going to return true and say there is a place meeting there. There we go. And there you go. We now have collisions. And they seem to be working quite well. You guys will have to test them out yourself. I can't find a way to break them. But yeah, look at this. Watch. Let's have the player draw to the GUI layer. Draw GUI. Draw the instance count. Draw text. Color. Let's do 16, 16, instance count. C white, C white, C white, C white, 0.75. Okay, you guys can look at this if you want, but this isn't actually necessary. I'm just showing you guys something. I thought I set that as a draw GUI event. Change, draw GUI. There we go. And now you can see, look at this. Our instance count is 2. There are 2 instances in this room, the player and the level. That's it. And yet we can collide with all of these walls just as if they were actual objects in the room. That is pretty cool. Now, if you want to make your, like I said, this grid place meeting isn't exactly perfectly foolproof because we're only checking the corners. If you want to make it a little bit safer, you can put in another one here, var center meeting. And you would just do level.grid xx div cell width yy div cell height does not equal floor. And then down here, let's see, where did I mess up? Oh, I forgot my equals sign. Center meeting equals level.grid xx div cell width yy div cell height. And then right here, just do center meeting. That's just checking the center location. So we're checking the 4 corners and the center of our sprite to see if there's a position on the cell. So that makes it pretty safe. You would have to have a huge player sprite that's way bigger than your grid in order for this not to work, which probably none of you will have. But yeah, that's it. We're just checking to see if the player's corners would touch a wall or a void cell if the player was in a specific position in the room. And then we're returning true if they are touching and false if they aren't touching. And that's how we can get this set up with the nice collisions. So thank you guys for watching. In the next part, I'm going to show you guys how we can do auto tiling in this room and make it look a little bit more 3D, just like I showed you in the first video of this series, so that we can create kind of a 2.5D effect and make the room feel a lot nicer. Right now it feels really random, and we don't want it to feel random. We want it to be random but not feel random. So I'm going to show you guys some tricks for how we can make it feel less random. Thank you guys for watching. Be sure and like and favorite this video. If also share it on Twitter. That really helps me out a lot. So I really appreciate you guys' support, and I will see you guys later in part 3.